All right, folks, I thought I would walk us through how to do the first couple problems in the online assignment that was on Friday. So it was DAW 3A, and it was the Big Ideas Math Online assignment. So I just thought I'd walk you through how to do the first three, what they're asking for, what it is you need to do. All right, so I've got the questions on the left here. All right, I've got what I'm doing on the right. So just a heads up, folks, if you're doing the online assignments, that's totally fine, but there's just a bunch of work going on in your head that possibly might want to happen on a piece of paper. So I want to show you what that looks like. All right, so here's question one. There's a diagram, and it's asking us, is it possible for this to be a straight angle? Use the diagram. So we're being asked to really carefully read this diagram. So I'm going to just sketch what I see, right? And I'm going to narrate what I'm seeing in this picture. All right, so we have an angle on the outside. It's called angle X, Y, W. They're trying to tell us really loudly that this is a 90-degree angle. If you didn't notice that, maybe just write 90 degrees. And then if we continue, we have another adjacent angle. This one's called WYV. There's one last angle, the third one goes VYZ. And then there's a little bit more info. There's a mark over here and it says this is a 46-degree angle. And then hopefully you notice there's a very similar looking mark over here. And when you use symbols like this, what that usually means is the angles are congruent, they're the same size. So even though it doesn't say so, what you really want to do is say, hey, you know what? Anytime I see this shape, that's a 46-degree angle in this diagram. So over here, this is also 46 degrees. So the question's asking, is it possible for this angle, the outside angle, this guy, to be a straight angle? I don't know if you can see this in the diagram, but it's actually bending outwards a little bit. If you add these, they add up to just a little bit more than 180. This is 182 degrees. So the answer to this is going to be no. No, not 180. And then there's only two choices for the no. It says no because this angle, angle X, Y, W, is right, 90. And because angle W, Y, Z is obtuse. Now, I didn't notice that when I was working, but I might notice that if I add these two, this adds up to 92 degrees. That's technically obtuse. It's bigger than 90. So this one's obtuse and this one's right, and that's too much. They don't add up to 180. They went over. So not 180 because angle X, Y, W is right, 90. And angle W, Y, Z is obtuse, which is 180. Well, it's more than 90. So they add up to more than one. Other more than. So, all right, 180 in the correct direction. So they add up to more than 180, right? That's why they're not a straight angle. Right. And then next up for part B, they're asking you, okay, how do you change this so that it becomes a straight angle? And I think our best option is to say, you know what, this 46 degrees, it was just a little bit too much. What if it was a 45? Right? If those guys were 45s, then we would have a 90 plus a 45 plus a 45, and that's 180. So the answer we want to pick for B is, what can you change? You can change both angle WYV and angle BYZ to be 45. So that's going to be option 2 right here. So, yeah. So those are the ones we wanted. Okay. All right. Next up, solve this equation. All right, so it's been a little while. I'm really sorry, folks. I forgot how long it's been since you did this. Let's talk about it. All right, so I'm going to write this down. So, and again, I don't know what you would be doing on your computer without writing stuff down to solve this. I would love if you could tell me, but let's try this way. So this is the equation we've got. Got a bunch of stuff that adds up to 180. There's parentheses. So I'm going to deal with those parentheses first. Now I'm going to look around. There's nothing in front of them. I don't have to distribute. There's no negative signs, so I'm not really worried about it. I'm just going to drop all of those parentheses. That grouping wasn't really doing anything extra. So I dropped all the parentheses. So deal with parentheses first. And then I've got a whole bunch of terms on the left, and I definitely would like to group like terms. So combine like terms. So if there's any x's, those can be combined. If there's any whole numbers that are positive or negative, they can be combined. So I'm going to look at the 7 and the 21. 7 plus a 21, so I'm going to get a 28. So those guys get mixed. And the second thing I'm going to look at is any x's. So I've got 6x and 13x, and those add up to 19x plus 28 is 180. So that's my next equation. And now I just want to solve for x. I'm going to rewrite that because that got really messy. So I want to solve for x. And basically what that means is I'd like the x to be by itself. There's too many things around it right now, so I want to slowly remove things until x is all alone and we figure out exactly what it is. So first thing I want to do is things that are farther away get removed first. So this 28, we can make that go away. So I'm going to do the opposite of adding 28. So that cancels because I made sure it would. I picked the minus 28 for that reason. I want to resolve what happens to my 180 degrees. So now I have 152 degrees. The 28's gone. I still have 19x left. Right, and my job was to solve for x, solve the equation. So now I'm going to remove the last thing attached to my x, which is this 19 times. The opposite of multiplication is division. I'll divide both sides by 19. And I have x equals 8. So that's the answer to number 2. Okay, now this next diagram, it got pretty complicated. So I really want to kind of walk you through this one. So the idea here is you got to read what it says, figure out what to draw, and then double check if your drawing managed to match what it said. So I'm going to sketch this diagram. I'm going to leave myself a lot of room because I'm going to be drawing all sorts of stuff in here. It's going to get messy. So what we're missing is a label for how big this angle might be. We're missing a label for the vertex, a label for this point, a label for this point, and a label for this point. That's what's missing. Okay, so now if I read the problem, hide my diagram, it says, in angle ABC, ray BX is in the interior of the angle. It's inside. Now I notice where it says angle ABC, the vertex, the middle letter is a B, and then it's talking about ray BC. So I'm pretty comfortable picking the middle of my angle, the vertex, to be a B. Okay, that's going to make this be ABC, or maybe it's ABC this way. And then this ray is going to be BX. So this other point right here is going to be an X. Okay. And then it says angle ABX is 12 more than 4 times angle CBX, and angle ABC is 92. So it says complete the diagram. And it says angle ABX is 12 more than 4 times angle CBX. So here's an angle that's already got a label. It's Y. This angle's missing a label. It's going to be an algebra expression. So this is going to be 12 more than 4 times the other angle. So it's going to be 4y plus 12 as information about how big this angle might be. And it said that angle ABX was 12 more than 4 times angle CBX. So I'm going to say this is angle ABX. The one on top, this is the bigger one. This is the one that has this expression. So that means CBX is this other angle, and I'm missing this point. So this is C. So that's how you filled in 3A. So you want to make sure that the labels for the names of the angles match what it said. So the big angle is angle ABC. And then if I translate what I've seen here, there's this angle on top. This angle is called angle ABX, or angle XBA. And then I'm going to say this angle plus this angle that's adjacent to it will add up to the big one. So the angle that's adjacent to it is called either XBC or CBX. Question already named it, so I'm just going to use what it had. So this is how this diagram fits together, right? So we have the outside angle with the ray on the inside and the 2 angles that are adjacent that add up to the big angle, right? So angle ABX, angle CBX add up to angle ABC. So notice the vertex letter is in the middle of all of these, and that's important. Okay, So for part B, it says write an equation to represent the situation. So I wrote this down. Right? This is me using the angle addition postulate. It's just a reminder to read the diagram really carefully and write down what you see so that you can then start turning this into algebra. So write an equation to find these two angles, use these expressions. So we have angle ABX is 4y plus 12. We have angle CBX is just plain y. And then the last bit of information is really hard to put in the diagram, but it did say in the text, it said angle ABC is 92. So angle ABC gets replaced with 92. So that's my equation. That's what I write in here. So I would write 4y plus 12 plus y. So that's my expression. It's really small, I can't see it. All right, and then lastly, it asks us to solve. Let's do that one more time. All right, so we're gonna deal with any parentheses. We don't have any. Then we're gonna we're gonna combine like terms. So I have 4y and y. That's gonna be 5y. Still have a 12. And then I'm gonna slowly work on removing stuff from my y until it's all by itself and reveals its secrets. So I'm gonna move this guy by subtracting 12. Gives me 80 equals 5y. So I'm almost there. I got one more thing I gotta do, but I have 5y and I don't want 5y, I want 1y. So I'm gonna divide this by 5. Unmultiply by 5. So now I have y is 16. So my job was to find the size of each angle. So angle CBX is 16 degrees, and that one's good. And then I also need to find the size of the other angle. I've got two choices. I can substitute in here. So I got 4 times 16, because y is 16. So that's 12. Got to figure out what that is. So 76. And then lastly, before I walk off, I'm going to double check that these actually add up to 92. They do. All right, great. So angle ABX is 76. Oop, on there. Angle ABX, 76. Angle TBX, 16. All right. Number 4, select 3 names for the angle. So you can go clockwise, you can go counterclockwise, or if it's not attached to another angle, you can just go with the vertex angle. So I'm going to call this angle G. I can't do that if it gets complicated, but if it's just hanging out by itself, angle G is fine. And then again, if I'm doing angle names, I want to go around the angle, clockwise or counterclockwise, instructing somebody how to walk around the shape. So I'm going to go angle FGH, FGH, and going the other way, angle HG. The G's got to be in the middle of names, though, so I'm not going to pick that one. There. All right. Finding the measure of an angle. Angle EOD. That is a tiny, tiny angle. So what I'm going to do is I'm going to subtract the 2 angles that it's pointing at. So this is pointing at either 40 or 140. I'll pick the small one. And this one's pointing at between 60 and 70, so 65. So it's going to be 65 minus 40. So it's going to be 25. Classify it. Well, it's 25 degrees. That's rather small. It's less than 90, so it is cute. All right. Let's do 2 more. So I'm going to do number 6. It says ABC is a straight angle. Find the measure of each part of it. Again, I'm going to write this down. So I'm doing number 6 on DAW 3A. Okay, so I'm going to write down what I see in this diagram. I see a straight angle. There's a big angle on the outside. Oh, let me draw it all. And you might think drawing is a bit annoying, but honestly, drawing will help you notice the things you need to make progress on this problem. So angle ABC is the big guy. Angle ABC is equal to 2 other angles that get added together that are adjacent. So this is ray BX. So I'm going to say this angle right here, this is called angle ABX. It's one of the things that needs to get added to be the big angle. This other angle is called either XBC or CBX. All right, so I see that. Next up, I have some expressions in there. So this is 14x plus 70. And this one's 20x plus 8. Just a heads up, folks, if everything's positive, it's much simpler than when it's not, so be very careful to notice if there's any negative signs. All right, so now I'm gonna substitute what I see to solve. It says ABC is a straight angle over there in the text, so that's 180. Angle ABX says 14x plus 70. And angle XBC says 20x plus 8. There's no parentheses, so my next job is to combine like terms. Sorry, and there's no good anymore. All right, so I'm going to combine my x's. I got 14x and 20x, so I'm doing 14 plus 20, 34 x's. And then I'm going to combine the 70 and the 8. They're both positive, so I'm just going to add them, so I get 78 degrees. Awesome, so that got less messy. So again, my job is to isolate the x so I can figure out exactly how big it is. So I'm going to slowly remove things that are far away until I can remove the 34. So we'll remove the 78. We're subtracting 78. So 180 minus 78 is 102. 34x. And this is a 0. So I'm going to, so close. Now I've got 34 x's. It's, a little too many. I only want one. So I'm going to divide by 34 to get rid of the multiplying by 34. So I'm going to do 102 minus divide by 34 on my calculator. 102 divided by 34 is 3 degrees equals x. All right, so this is super helpful. We need it, but we're not done. What we're going to do is then substitute it back in to find each angle. So I'm doing 14 times 3 plus 70. 14 times 3 plus 70. 112 degrees. This is good. This is obtuse, and that angle certainly looks obtuse, so that's good. That means I'm on the right track. And this other one, same deal. I'm going to substitute, so it's going to be 20 times 3 plus 8. So that's 68. And then just before I leave, I'm going to double check if these actually add up to 180. They do, so I must be right. Awesome. So then I'm going to put size angle ABX, the bigger one, the obtuse one, that was 112. And angle CBX. All right, last one I want to do. Number 7. If you need anything else, let me know if you want me to do anything else on the video. But for right now, let's say that's good enough. So number 7, this one's slightly different because this one is about things bisecting, which means cut exactly in half. So I'm going to draw this again. And before I complain about drawing too many things, it's okay. It's helping me read the diagram slowly and carefully. So we got Q as our big vertex. We got P as the outside. R is the other outside. And we got... So it is telling us that ray QS bisects angle PQR. So big angle gets cut in half by ray QS. Angle PQR got cut exactly in half by ray QS. And what I can do with this information is I can put fancy symbols on here that match, which says these two must be the same. These two angles are identical. All right, now angle PQR is large. If I really want to, I can use angle addition postulate here, but it's not that helpful. But basically, each of these is half of angle PQR because it got cut in half. Right? That's what bisect means. So it's going to be half of 119. It's a little awkward, but it's just a 0.5, so it's 59.5. This one also got cut in half. Same. And we got to add up to 119. So bisect, cut exactly in half. Same number twice. All right. 59.5. And then, folks, I'm going to recommend that you get really friendly if you like the online Big Ideas math experience that you get really friendly with checking your answers, you can check your answers 3 times before it stops giving you feedback. You can watch videos that are like this problem if that's an option in the problem, or you can ask for a live tutor. So I'm going to encourage you to try all of